we go with our video lesson on 8.1. Again, remember the best way of doing this is to try the problems yourself and then pause the video, try it yourself, and then watch me do it. So here we'll warm up, and it is kind of cold out here today. This is our last day that we're allowed to come into campus, so I'm actually here grabbing some stuff and thought I'd record these here. So anyway, yeah, an extra layer is nice. I actually have an extra layer on. Okay, so go ahead and graph y equals negative 3/2 x plus 2. Pause the video, and then I will go through it. Okay, so I notice it's in y equals mx plus b form, so I know that one point that I can go to on my graph is 0, 2, because that's the y-intercept, and the slope of negative 3/2 means to get a second point from my y-intercept, I can go down 3 and to the right 2 and draw a line, or put a point and then draw a line, or I could have gone up 3 and then to the left 2. Remember, just one negative direction, one positive direction. And notice how that point, and that point all line up. I'm doing these on Desmos, so keep in mind that it doesn't put an arrow, but when you do yours, they should have arrows on them. Okay. All right, so go ahead and do these. Try and do them a shortcut way if you can. All right, so I'm back, and hopefully you recognize that was just a binomial squared, so hopefully you did it the fast way and not by foiling. This one definitely is a binomial squared, so remember, square the first term, double the product of two terms, square the last term. This you would just FOIL. Here you would do what? Yep, distribute. And here you would FOIL as well. Okay, so hopefully you got those. All right, so our learning target in purple will be to be able to describe the characteristics of the graph of a quadratic equation, or quadratic function, excuse me, in the form of f of x equals ax squared. Okay, so remember, quadratic equation is where we have the highest degree is to the second term. Quadratic function just means f of x, and remember f of x is just, or g of x is just the same thing as y. So basically a quadratic function is the same as a quadratic equation. So we're going to learn like what graphs look like, and that's what chapter 8 is really a lot about, is kind of graphing and taking a look at what quadratic graphs look like. Okay, so on your graph that you have there, you have what f of x equals 1x squared, or just x squared looks like, and we're going to graph g of x equals 3x squared on the same graph, and then we're going to compare what it looks like to what we call our parent function, which is this one. So the way we're going to do that at this point is basically just plug numbers in for x. So if I plug a 0 in for x, then I get 0 squared times 3, which would be 0. And then you can go and plot that point. Okay. If you plugged 1 in, it would be 1 squared, which is 1 times 3, which is 3. If you plug 2 in, 2 squared is 4 times 3 is 12. Is negative 1 going to get me the same thing as 1 got me? Remember, when we plug in the negative 1, we put it in parentheses. So yes, because negative 1 quantity squared is 1 times 3 is 3. And obviously negative 2 would be the same as 2. So if you went and plotted all those points, you're going to get a graph that is in blue here. Okay, so you can see 0, 0, 1, 3 is right there, negative 1, 3 would be right there, 2, 12 is all the way up here, or negative 2, 12 is up there, and positive 2, 12 is up here. The red is what our parent function is, the f or x squared. So how would you compare what we just graphed, the blue, to the red? Well, you might say it has the same like lowest point, which is actually called the vertex. But in terms of the way the graph looks like, you might say that ours is steeper. Okay, so keep that in mind. Notice our coefficient, our leading coefficient here was a 3, and here again it's just 1x squared. Okay, so let's do the same thing for g of x equals negative 5x squared. Why don't you go ahead and try it? And you can pick any numbers to plug in for x squared, but you don't need to get real fancy about it. Just use kind of like numbers that are smaller and easy to use. So go ahead and try that. Okay, back. So what I plugged in was 0, and obviously if I plug in 0, then g of x is equal to 0 as well. I also plugged in plus or minus 1. Again, that's going to give me the same thing, right? Because either way, when I square that, I get 1, and then times the -5, I get -5. So I actually have 2 points that I can plot that. So I'd go plot 1, -5, and also I'd plot -1, -5. And then I think I also did plus or minus 2, which got me -20. So then go plot those points, and I would get this blue one. Again, this is our parent function up here. This is the f of x equals x squared. So how would you compare what we did? Well, it opens downward, right? So, and it's also steeper. Okay, and we're going to learn all about kind of the rules for this as we go on. Okay, so we had to do those ones by hand. This one is asking us to use Desmos. Now, I showed you how to get to Desmos when we did the 8.0 exercise. So remember, you go in big ideas, hit the 3 bars in the upper right, click on Math Tools, then High School, because it's a high school class, and then do not the Desmos geometry tool, but the one that's on the right, the graphing calculator. So you could actually plug those in if you wanted to kind of compare. So you can go ahead and go do that. Pause your video. And hopefully that worked well for you. And hopefully when you graphed it, you got something that looked like this. Again, this is our f of x equals x squared. This is our -2 or -0.2 x squared one. So how would you describe it? Well, it opens down and it's shallower, which means it's more bowl-shaped rather than like steeper. Okay. So go ahead and do the same thing for g of x equals 1/10 x squared. So go ahead and pause the video, go to Desmos and do that, and then kind of describe what you see. All right, back. So again, this is our 1/10 x squared. This is our parent function of x squared. And what do you notice? Well, opens the same way. It opens up, but it's definitely more bowl-shaped or shallower. Okay, and you're going to start seeing that coefficient makes a difference. Here was a -1, and it opened down. Here's a +1, it opened up. This one's less than 1, and it was shallower. We went back here. Here's a positive number, so it opens up, and greater than 1, and it was steeper. Here it's a -5, so it opens down, but it's steeper. Okay. All right, so characteristics of quadratic functions. You've heard me talk about the parent function. So the parent quadratic function is f of x equals x squared, or 1x squared. The graphs of all other quadratic functions are transformations of the graph of the parent quadratic function. Transformation just means like we're moving it or changing the way it looks or making it more shallow or making it steeper. Okay. The lowest point on a parabola that opens up or the highest point on a parabola that opens down is called the vertex. So you can see that here. This is one that opens up. If we had one that opened down, that would also be the vertex. Okay. The vertex of f of x equals x squared, our parent function, is 0, 0. Meets right at the origin. Okay. The vertical line that divides the parabola into 2 symmetric parts is the axis of symmetry. Think of it this way. Pretend this was like a taco and you wanted to fold your taco over. If I folded this over to here, I would do that right along the axis of symmetry. Okay. So for the graph of f of x equals x squared, the axis of symmetry is the y-axis. In other words, x equals 0. Because remember, we name a vertical line by what's true of all the x coordinates. In this case, every single point on this line has a x coordinate of 0. Okay? All right, so consider the graph of the quadratic function. Using the graph, you can identify characteristics such as the vertex, the axis of symmetry, and the behavior of the graph is shown. So if you look at this, what do we know? Remember the domain, that's like all the possible x values? Well, this is going to be a domain of all real numbers, right? Because this would continue up get steeper and steeper, but if we went to infinity, we'd basically keep going this way, keep going this way, and keep going this way, keep going this way. So the domain is all real numbers. We've worked on that before. The range is going to be what? Well, if this is our lowest point, we never go below -2 on the y-axis, right? So our range is going to be all real numbers greater than or equal to -2. So you could write that as y is greater than or equal to -2. Okay, and then what does this say? When x is less than -1, so when x is less than -1, which would be this part of the graph, as x decreases, what happens to the y values? It increases, okay? And when x is greater than -1, the blue part of our graph, as x gets bigger going this way, what happens to the y value? It increases, okay? What's our axis of symmetry here? X equals -1. Our vertex, -1, -2. Okay, so what I want you to do on these is actually identify the characteristics of each of these. So go ahead and do the one on the left. Okay, we're back, so I'm going to start uncovering and going through it. So the domain here, hopefully you got all real numbers, because again, this will extend out forever this way, and eventually we'll hit all x coordinates. What's the range? The range, since it's opening up, and it looks like this is -3, so it's going to be y is greater than or equal to -3. Our axis of symmetry is this line right here. Go ahead and put that in. Let's do that. So there's our axis of symmetry. So what would we call that? That would be x equals 2. And our vertex obviously is that point right there, which is to -3. And when does y decrease? When x is less than 2, okay? So it's coming down when x is less than 2, okay? All right, try the next one. Okay, I'm back. Hopefully you got the domain was all real numbers. This one's facing down, so our highest point on the y-axis is 7, so it would be y is less than or equal to 7. Our axis of symmetry is right there. What would we call that? X is equal to -3. Our vertex is right there, -3, 7. And when does the function decrease? When x is greater than -3. Okay? So as we move this way, the function's increasing, right? But as soon as our x gets to -3 and starts getting bigger than that, the function decreases. Okay, so that's really all you need to know for the first homework assignment. So one thing you could do is you could stop the video here and then, well, actually we're doing the homeworks in class, so never mind, keep going with the video. Okay, so now let's get into a little bit more specifics, and we've already kind of talked about this, but here's the situation when we're graphing f of x equals ax squared where a is greater than 0. So we're talking about a positive number. It could be a positive number that's less than 1, like 1/2 or 3/4 and so forth, or it could be something that's bigger than 1, like 1.5 or 2 or 10 or 20. Okay, so when a is between 0 and 1, meaning a fraction, right, like 1/2 or 3/4 or 2/3, but positive, the graph of that is going to be a vertical shrink of f of x equals x squared. So here's our parent graph in blue, okay? So a shrink is kind of making it more bowl-shaped, okay? So that would be the red one here, okay? So that would be the red one. If a is greater than 1, like 2 or 3 or 4, then what we're going to have is what we have in green, which is steeper than the blue one. So the green is steeper than the blue, okay? Now, very similar when a is a negative number, When it's something that's between 0 and -1, like -1/2 or -2/3, then it's going to be more bowl-shaped, or what they call a vertical shrink. Okay. When a is less than -1, like -2 or -3 or -10, then it's going to be what we call a vertical stretch. So it's a vertical stretch. Steeper. Okay. And again, remember f of x is like y. Okay. All right. So let's try some of those. We're going to graph g of x equals 2x squared, and we're going to compare it to our parent function of f of x equals x squared, or 1x squared. I've given you the numbers to plug in, so go ahead and plug those in, graph it, and then kind of come up with the comparison. Go ahead and pause the video. Okay, I'm back. So hopefully you had 0, and if it was plus or minus 1, you got 2, and plus or minus 2, boom, we jump up to 8. So what do we have here? Ours is in blue. The red is our parent function. So the blue one is, hopefully you said, is steeper. It's a vertical stretch, has the same axis of symmetry, and same vertex. So that would be a way you could describe that. Okay, let's do another one. Again, go ahead, pause it, try it on your own. I've given you the x values to plug in to figure out our y values or h of x values. Think about what you think this one's going to look like, though, compared to the parent function. Okay, we're back. So if I plug in plus or minus 6, I have 12. And because that's 6 or -6 squared is 36, and then times -1/3 is -12, plus or minus 3 gets us 9 times -1/3 is -3, and obviously if we plug 0 in, it's 0. Okay, and your graph would have looked like this. So how would you describe that? Well, it's opens downward, right? It's got the same vertex. It's a vertical shrink. In other words, it's more bowl-shaped, right? And it has the same axis of symmetry. And that axis of symmetry would be the y-axis, or where x equals 0. Okay. All right, let's try 5x squared. Do the same thing. Go ahead and pause it. And I'm back. So hopefully when you plug these in, you get 0, 5, and I used 1.5 because this is going to get really steep really quickly. And I got 11.25. Now, if you graph that and it's not exactly in the right spot, that's fine. It's going to be pretty hard to graph perfectly. But you should have gotten something that was steeper. Same vertex. And obviously the same axis of symmetry would be x equals 0. Okay, take a look at h of x equals 1/3 x squared. What do you think it's going to look like? Okay, go ahead and try it. Okay, so 0, 1/3, 3, and 12. So this is ours that we just did. This was our parent function. So how would you describe the blue as compared to the red? Well, you would say that it's vertical shrink, meaning it's more bowl-shaped. It's got the same vertex, obviously, and the same axis of symmetry. Okay. All right, 3/2 x squared. Go ahead and try these. So obviously 0. If I plug in a 2 or a -2, I'm going to get 4 when I square it, and then 3/2 times 4 gets me 6. You can pick any other number, but obviously it's going to get pretty big pretty quickly. I use 2.5. And if I use 2.5, I get 9.375. Again, you don't have to do that, but it's really more about kind of trying to get a better sense of what the graph's going to look like. So ours is the blue, which makes sense because this is a coefficient that is bigger than 1. So it opens the same way, it's a vertical stretch, and same vertex, same axis of symmetry. Okay, take a look at p of x equals -3x squared. What do you think it's going to look like? go ahead and try it. You pick the numbers. I picked 0, which gets me 0. I picked plus or minus 1, which gets me -3. And I plugged in plus or minus 2, which gets me -12. Because 2 or -2 all squared is 4 times -3 is -12. And I graph those points. And you can see just the very top of my parent function there. I had to do it this way in order to get my graph in. And how would you describe it? Well, it's steeper, right? So opens downward, so it's a vertical stretch, steeper, and same axis of symmetry, same vertex. Okay. All right. -0.1 x squared. You go ahead and pick points that you think make the most sense. I will uncover my points first here in case you want to see and do the same ones that I do. So let me do that. So I use 0, plus or minus 1, plus or minus 3, and I use plus or minus 5 just to get a better sense on this one. So go ahead and try it. So this obviously is 0. This is -0.1, so wow, it's really flat, isn't it? So you can see why I wanted to do to get something that was kind of going up a little more, or I should say down. But okay, so this is ours. This was our parent function. So how would you describe it? A lot of ways. Opens downward. It's got the same vertex. It's a vertical shrink, meaning more bowl-shaped, and in the same axis of symmetry. Okay, and here's another one, -1/4 x squared. Here are the numbers that I plugged in if you want to use the same ones. So go ahead and try those. Okay, so I've got 0, -1, -4, and -9. Just to show you example one, like if I plug 6 in, that's 36 times -1/4 is -9. So we've got actually, 7 points to plot there. And again, parent function's there. R's negative coefficient is going to open downward. It's going to be a vertical shrink. It's kind of flatter, more bowl-shaped. Kind of what we want for the coronavirus, I guess it'd be like this one, huh? Nice, really flat. Anyway, same vertex. Vertical shrink, same axis of symmetry would be our y-axis, x equals 0. Okay. All right, so here we have a diagram, a cross-section of a satellite dish where x and y are measured in meters. Find the width and depth of the dish. Okay, and they give us y equals 1/4 x squared is the equation for this parabola here. So you can see the width and depth. You can pretty much do this in a number of ways, but you can probably see just from looking at the diagram what they're going to be. So go ahead and try and do that. So we know the leftmost point in the graph is -2, 1, and the rightmost is 2, 1, right? So the domain would be x is between -2 and 2 inclusive. Well, what's that distance? It's 4 meters, right? And the depth, you can see, is 0, 0 up to what? 1. So that means it's 1 meter in depth. And that's what you have. Okay. Okay, so now we have a spotlight. And the graph for that is y equals 0.5 x squared, where x and y are measured in inches. And we have x is, the domain is between -2 and 2 inclusive. So find the width and depth of the spotlight. Okay. Well, you could probably see and recognize what the width is going to be just from looking at this. Well, let's go ahead and graph it to get a better sense of it. So we can plug in 0, 0, plus or minus 1, and then we don't want to go with anything that's either less than -2 or greater than 2 because we're told that the domain is restricted there, right? So if you plug those in and then graph those, this would be the full parabola, right, if we kept going. But really, we're just looking at this part right here. So it's almost like you want to cover this up and cover that up. Okay, so obviously from here to here, that's a distance of 4 inches. And from here to here, that's a distance of 2. So our depth, or it's 2 inches deep and 4 inches wide. Okay, and then for your exit ticket, I want you to describe the differences between the graphs of y equals negative 3x squared and y equals 1/3 x squared. So think about what the differences would be. Try it on your own. Okay, so hopefully you recognized a number of things. One, this one opens down because it's got a negative leading coefficient. This one opens up because it's got a positive one. This one is narrower. In other words, it's a vertical stretch, right? It's steeper than our parent function. This one's going to be wider, right? Because it's between 0 and 1 for its leading coefficient. What else do we know? The range for this one is y is greater than or equal to 0. The range for this one is y is greater than, less than or equal to 0 because it opens down, right? So in other words, the vertex is at the origin. And here, the vertex also at the origin, but it opens up. Okay, so that does it for the lesson on 8.1. Hopefully you have a good understanding of this. You can always go and do some practice problems, but I would hold off on starting the homeworks. We'll do those together after we take questions on the lesson. All right, hope you had enjoyed this, and I will talk to you soon.